So let's look at a different concept now called DFA path function. So we saw transition function in DFA. Right? In DFA we have a set of states Q, alphabet, single start state, set of final states and transition function delta, right? We saw transition function. Delta is a function from Q cross sigma to Q, where Q cross sigma is the domain and Q is the range. We saw delta is a two-variable function. It takes some state Q and some symbol A belongs to sigma and outputs which state it goes. Where this particular transition in the transition diagram looks like this: Q0 if it's season A goes to Q prime. Right? This is what we saw about normal transition function delta. Now let's look at a path function, which is simply so we denote path function by delta hat at the top, and its domain is Q cross sigma star in this case to Q. So in the previous case we saw it's Q cross sigma. In this case it is sigma star, which is set of all possible strings. Right? So delta hat is again a two variable function. Takes a single Q and in this case takes a string and outputs which state Q prime. So delta we have to specify, right? For every Q comma A pair we have to specify Q prime where it goes for delta. That's how we define the transition function delta, right? We have to specify we have to give delta as part of DFA. But delta hat is derived from delta, not a core DFA description. So delta hat basically means if you are at state Q, upon further reading string X, where will you end up? You will end up at Q prime. We just write it as delta hat of Q comma X equal to Q prime. If you are at currently state Q and furthermore you read string X from Q, then you will end up at Q prime. We will always end up at a particular single state because your DFA, it's a deterministic machine, right? For every state you have exactly one transition of which state to go for every symbol, right? So if you read your whole string X character by character, so at every state you will move to one other state exactly, right? So after reading the whole string you will exactly end up in a single state, which will be your q prime, which we write it as delta hat of q comma x. You start at q and you read string x, delta hat of q comma x will be the state you end up at. So this function output is again always a single state. Okay. So how do you mathematically define delta hat? Delta is a given function, but delta hat you have to derive using delta. So delta hat has some properties. Okay. So first thing is delta hat of q comma epsilon. This is always q itself. Right? If you are at a state and you read an empty string, you will just stay there. And delta hat of q comma a, where a is a single character, a belongs to sigma. This will be exactly delta of q comma a. Where delta is your transition function, normal transition. You are at state q and you read a single character a. Delta hat of q comma a will be your delta of q comma a simply. And third one is delta hat of q comma wa, where w is some string and a is some single character. This will be delta of delta hat comma q comma w comma a. These are definitions of, this is basically the whole definition of delta hat. Right? So look at the third property. This is basically simply saying if you are at some state q and you read a string of the form wa, where you just know the last character, this is simply simply just you start at q and you just read till w, and delta hat of q comma w will be the state you end up at. And from that state you just have to do a single step transition for reading character here. So that's the main, that's the whole what it means. And then based on these three properties we can actually give a fourth property. Fourth property is delta hat of q comma xy equal to delta hat of q comma x comma y, where x comma y are some strings. Okay. So q comma x, xy is basically x concatenated with y. It's a whole string, and this is basically equal to, you just start at q and read till x, and from that state read y. That will be our, that's the whole thing. Yeah. So this fourth property is actually provable These first three are given definitions. We don't prove those. But this fourth property is derived from 1 to 3 properties. We can actually prove this using mathematical induction, which is lengthy. We do not require. I actually proved it in section A and B. We don't require it, but it's a nice to know fact. Yeah. So let me give some examples. Say for example we have some language L which represents something, and let's say its DFA is this Q0. And Q1 and Q2, where Q0 is your final state, and this language is constructed on sigma is 0, 1. So 1, and just to give an example of a DFA, okay, so let's consider this a random language with a given DFA. This is not a random language. We actually saw this example. This is, I think, L8 example we saw. This accepts all strings which are binary representations of multiples of 3. So let's see what delta hat of q1 comma string 1101 will be. So what will be the answer for this? So you start at q1 and read 1101. So q1, okay, just my mistake. If you are at q1 and if you read a 0, you will go to q2, but if you read a 1, you will go to q0. Okay, now the DF is okay. So now tell me, if you read a q1 and then 1101 string, where will you end up? So start at q1, read first character 1, you will go to q0, and then again for reading next one, you will go to q1, and then for reading a 0, you will go to q2, and then for reading 1, you will stay there. So delta 1 of q1 comma 1101 will be q2, and similarly delta hat of q2 comma 000, what will this be? So start at q2, read a 0, you will go to q1, and read the next 0, you will come back to q2, and read the third 0, you will go to q1. So your answer will be q1. So this is all delta hat. Why we use this? Because at the end we can just say if delta hat of q0 comma x belongs to f. This is if you start at start state q0, right? You have your start state Q0. Every DFA has your start state Q0. And if you read an X, you will end up in some Q prime. And if that Q prime is one of the final states, then you say you accept X into the language, right? We will see more of delta hats later. We will see them in NFS also.